Noel Duffy from Cyro. We're kicking off the second half with a bang. Flexible, integrated energy devices. Noel.
Thank you very much, Lenny. I'm actually going to talk about some work that's not mine, but it's in an area that I've worked in. And basically, we had a client that came to us, or we put in for, that wanted to overcome their energy management issue, or actually get away from having to carry large amounts of batteries. And so they wanted a wearable energy generation, energy storage device that was flexible, could be integrated to their clothing, and seemed to be a long way into the video, and could power their electronic devices. And this was a military funded application, and the solution, there was a number of solutions that you could have for this. There was solar panels put forward around their helmets, but the solution that we came up with was wearing batteries on the vest and vibrational harvesting units on the shoulder straps of their wear. And there's some big challenges with that, because at the time when this project kicked off, there was no flexible battery available. And so there's all the things with making flexible battery, making fibres that can hold electroactive materials, weaving those fibres, making them strong enough to hold together. And so there was, and making them integratable with weaving technology as well to make the fabric. Particular one is that most lithium metal batteries, which came out on the market a long time ago, you might have heard, laptops catching fire. The last thing you want is to be wearing a battery that catches fire, especially for a soldier. And so there was a big development in that electrolyte that is safe and can be wearable. And then developing on from that, we had to find strength for that fabric. So to make it a conductive fabric, by making a coating, a conducting polymer coating, to make it an active material, but also to give it some strength. And so there was weaving of wool and stainless steel to make a new fibre or yarn that then was woven with pure wool and stainless steel to make a cloth. And that cloth turned into the active anode or active cathode. And then on the other side of the battery, you need two parts. You need sorry, mate. And then for the other part, you need to deposit the lithium metal onto a flexible substrate as well. And we just used a nylon material for that. And the final part is the harvesting unit. And so what it has a vibrational rectifier and a transducer that turns any motion. So if you're walking, this thing vibrates up and down and turns into electrical current. And then that can be coupled to the battery for storage or to directly power a soldier's electronic devices. And so a lot of testing was gone in the lab on how to optimize that, and then data log is built to then test that in the field to optimize it. And then, of course, the final part is combining both the energy generation and the energy storage into something that the soldier could wear in the field to power those electronic devices. And that was basically the project. And we're at the stage now, or I believe the project's at the stage now of actually going into field trials with a wearable vest. And the idea is to reduce the amount of load that a soldier has to carry in terms of batteries. There's a lot of batteries they carry to power their devices. And if we can take that weight off, then they can carry more things beneficial to being a soldier.
One question from me, non-military applications?
So the thing that I'm really interested in is I did a lot of adventure racing and a lot of search and rescue. And one of the things that you always hate there as well is when you're out looking for someone and you carry lots of batteries, your headlight goes flat, and or you're out racing at night and you've got to carry more batteries, then having it, and you've always got a backpack with you, and so obviously place to integrate these vibrational units is into the straps of the backpack and fit the battery packs in there. So that is something that's worked out, and there's a test product done with a manufacturer of backpacks.
A New Zealand-based manufacturer of backpacks?
Well picked up.
That we can't name?
I don't think we can name anyone. But so there is, that's an avenue being explored. Obviously, the big one is people wanting to not have to find somewhere to charge their mobile phone. Right. So if you could, charge your mobile phone by wandering around.
Go for a walk, charge your mobile phone up.
Correct. Yeah.
What's the most exciting thing on the horizon?
I think it's the getting away from modularising it, so like having a separate battery and a separate energy harvesting unit, and putting that into an active material, so that you just wear the material and just have your USB plug and you don't lose form factor.
Right. Just amazing. Yves Saint Laurent, and you charge up your Swiss watch. That's amazing. Questions? Yep.
How much power do you think you can generate from this device? How much would it cost?
The cost to produce is an interesting question. I'll take that first, because I suppose it depends on your metabolic rate, right? But in the treadmill example that you saw on the screen, the initial testing over, say, a 2-minute walking period, and if you're carrying between 5 and 15 kilos, you can generate about 10 watts peak. So if you land particularly hard, but if you walk softly or you average that out, you generate about 1 watt per 2 minutes. We used to do it per hour, but everyone went, walking for an hour? 2 minutes is what I want to know. So about 1 watt in about a 2-minute period of walking at, with 5 to 15 kilos of weight.
Question here. Is there a question at the front? Yeah.
So the energy harvesting unit is probably the most efficient, or there's nothing else that matches it at the moment on that's in development or on the market. The added weight of the electronics is not that significant compared to the battery, the removal of the battery packs that they have to carry. To do the same power jobs, and especially if they can get rid of recharging stations. But more importantly is that what we're doing is what's being done is they're integrating the battery inside aramid fibre pouches, which are already in bulletproof vests or in stab-proof vests. So you make the battery part of the bulletproofness or safety.
Effectively no additional weight.
There is still an additional weight.
But nothing compared to the batteries.
Yeah, correct, yeah.
More questions? Yep.
Is this at all comparable to piezoelectric energy generation?
So yes, so a vibrational energy harvester is exactly like that, like piezoelectric generation, where you move it, something's moving and generating a charge. So yeah.
Have things like a car drives over it and you generate energy?
So there is so they can be used anywhere where you can think of having. You want to convert motion or mechanical energy, if you want, or that into electrical energy. So that's what they'll do. So.
The thing that governs your generation is the frequency or the
No. So there's a transducer in there, and it's a rectifier. So it's the amount of force will give you that peak power. The amount of force will give you the peak power, but there's a transducer which is like a capacitor, so you can take out the frequency components of the walking, and the rectifier makes certain that any motion is captured.
One question at the back.
Yep.
How does it handle wireless array
Yeah, so the battery part is in where normally the Kevlar armour would be. So sweating there, it doesn't cause any more or any less, if that's what you're asking. So the breathability is not compromised of the webbing because there is no breathability in those parts. And the vibrational energy harvesting unit is again quite small compared to the surface area of the webbing that will allow sweat or allow your skin to breathe.
All right, last question.
This might be off topic, but you say it's lithium in the vest that you're using?
So currently the batteries are positioned in front of it because on the military they wear
But the actual
the battery, this flexible battery, is inside the material or inside the fabric of the vest.
lithium battery.
So so it's a lithium metal battery.
So what? Just because you're using it in military applications,
Yep.
what happens to the soldier when he gets hit by a round?
Okay, so there has been bullet tests done, and that's why we use a special electrolyte that won't burst into flames. So it's not like the original lithium metal battery in the laptops. So that's right. And because it's flexible also, if you flex the battery, you don't want it to short. If it shorts, you don't want it to catch fire. So we have a special separator as well. So.
All right, so that's great news for wearers of this stuff. You're not going to catch fire when you get hit by a round.